Okay, this video talks about percentiles and standard deviation. Standard deviation is a way to measure the spread or the variation in a set of data. If you think about the scores on a math test, when we find the range, we're looking at the maximum value minus the minimum value. So that will just tell you the difference between the score of the highest student and the score of the lowest student. The IQR, the interquartile range, is where you take Q3 and you subtract Q1. That tells you how far apart the middle 50% of the data is. So we get rid of the top 25%, the bottom 25%, and that tells us the difference between the 75th percent and the 25th percentile of the data. The standard deviation is the average distance from the mean, and we'll talk a little bit more later on about how to calculate that. But a few things about the standard deviation. It's how far away you are from the average. Because we're talking about a distance from the average, that means it's always positive. Since we're looking at the mean, it is affected by outliers. So if you had a value that's much larger or much smaller than the majority of the data, it will affect the standard deviation. It relates to X bar. X bar is just the mean of a set of data, what we normally call the average, and 0 is the mean. So if you say 0 standard deviations, that means you're at the mean of the data. If we look at this first data set here, they're all 5s. Since it's a uniform data set, there is no variation in the data, so the standard deviation would be 0. If we look at the next two data sets, 3, 4, 4, 5, and 6, is a those data values are very close together, so it would have a small standard deviation. If we look at the set 1, 7, 10, and 20, those are more spread out, so those would have a larger standard deviation. One way where standard deviations are used is to look at a normal distribution. A normal distribution is just like a bell curve. It's where the mean and the median are in the same spot. If you go one standard deviation above the mean and one standard deviation below the mean, that will be 68% of the population. That is, 68% of the population will fall within one standard deviation of the mean. If we go 2 standard deviations from the mean, that means that 95% of the population, or 95% of the data, will be within 2 standard deviations of the mean. And if you were to go 3 standard deviations from the mean in each direction, 99.7% of the population will fall in within 3 standard deviations. Now let's look at a real-life example. If we look at women's height in the United States, the mean or average woman's height is 5 feet 4.5 inches. So that's marked right in the middle where we have the mean. The standard deviation is 2.5 inches. So what that means is when we go 1 standard deviation above and below the mean, that 68% of the population of women in the United States will be between 5'2" and 5'7". If we were to go 2 standard deviations above and below the mean, that means that 95% of the population of women will be between 4'11.5" and 5'9.5". And then if we go 1 standard deviation further in each direction, so that means if we go out 3 standard deviations in each direction, that 99.7% of the women in the United States will be taller than 4'9" and shorter than 6 foot. So we're going to use that kind of idea to see how we would answer these questions about standard deviation. So number 1 says you just received your MCA math test results. The printout says you scored 2 standard deviations above average. Is that good news? If we go back here, if you're 2 standard deviations above the average, that means that you scored better than 95% of the students. So I would say yes, that would be very good. Number 2 says Mrs. Larson received blood work test results and found that her cholesterol level is 3 standard deviations above the mean. Is that good news? That would be very bad news. If she was 3 standard deviations above the mean, that means her cholesterol would be higher than 99.7% of the people. That would actually be a very bad thing. Next says John scored 3 deviations above the mean on his ACT. Sue scored 1 deviation below the mean. Who did better? Well, John did better because he scored above the mean and Sue scored below the mean. Carl is 2 deviations below the mean for height. Is he short or tall? If he's 2 deviations below for height, that means that there are 95% of the people that are taller than him. So that would mean that he was pretty short. Bill Gates is very intelligent. It is estimated that his IQ is 0, 1, 2, or 3 deviations above the mean, and let's circle 1. So let's think about this in terms of percentages. If we said that he was 0 standard deviations above the mean, that would mean he would be average. Well, if he's very intelligent, he's more than that. If he's 1 standard deviation above the mean, that would mean that he would be smarter than 68% of the people. Well, he's probably a little more smart than that. So then if we said 2 standard deviations above the mean, that would mean that he would be smarter than 95% of the people. Well, that still is pretty good, but I would say he would probably be a little more exceptional than that. If we said he was smarter than 95% of the people, that would mean that out of every 100 people, 5 of them would be smarter. And I don't really think that that's the case. If we went 3 standard deviations above the mean, that would mean that he would be smarter than 99.7% of the population. That means that only 3 people out of 1,000 would be smarter than him, and I think that would probably be a pretty accurate reading. Okay, go ahead and take a look at number 6 and see what you think about that one, and see if you can arrange those in order from the lowest score to the highest score. Okay, and once you're done with that, that will conclude this video, and look for the examples in the next video.